day everyone. So for today's video, we'll tackle about the trigonometric identities. Before we proceed, let me present to you our objective. At the end of the lesson, the student should be able to use the trigonometric identities on proving. Trigonometric identities are equalities that involve trigonometric functions and are true for every value of the occurring variables where both sides of the equality are defined. The tan cosine hexagon, which use various ways to remember various trigonometric relationships. The first one is reciprocal identities. First is sine theta is equal to 1 over cosecant theta. In alternative forms, cosecant theta is 1 over sine theta. Cosecant theta, sine theta is equal to 1. The second one is cosine theta is equal to 1 over secant theta. In alternative forms, secant theta is equal to 1 over cosine theta. Secant theta cosine theta is equal to 1. The third one is tan theta is equal to 1 over cotangent theta. In alternative forms, cotangent theta is equal to 1 over tangent theta. Cotangent theta, tangent theta is equal to 1. Letter B, quotient identities. First is tangent theta is equal to sine theta cosine theta. In alternative forms, cosine theta is equal to sine theta over tangent theta. Sine theta is equal to cosine tangent theta. The next one is cotangent theta is equal to cosine theta over sine theta. Sine theta is equal to cosine theta over cotangent theta. Cosine theta is equal to sine theta cotangent theta. Letter C is the Pythagorean identities. First is sine squared theta plus cosine squared theta is equal to 1. In alternative forms, sine squared theta is equal to 1 minus cosine squared theta. And cosine squared theta is equal to 1 over sine squared theta. The next one is 1 plus cotangent squared theta is equal to cosecant squared theta. In alternative forms, 1 is equal to cosecant squared theta minus cotangent squared theta. And cotangent squared theta is equal to cosecant squared theta minus 1. The last one is tangent squared theta plus 1 is equal to secant squared theta. In alternative forms, 1 is equal to secant squared minus tangent squared theta. Tangent squared theta is equal to secant squared theta minus 1. So this is the sine tan cos hexagon. The quotient identities. All of the quotient identities can be found by either going clockwise or counterclockwise around the hexagon, which is this figure. Clockwise is first tan x is equal to sine x over cosine x. Sine x is equal to cosine x over cotangent x. Next is cosine x is equal to cotangent x over cosecant x. Cotangent x is equal to cosecant x over secant x. Cosecant x is equal to secant x over tangent x. secant x is equal to tangent x over sine x. The product identities, for the product identities, a function between any two functions is equal to those two functions being multiplied. For two functions opposite each other, their product is equal to 1. For examples, sine x cosecant x is equal to 1. Tangent x cosecant x is equal to secant x. Sine x secant x is equal to tangent x. Tangent x cosine x is equal to sine x. Tangent x cotangent x is equal to 1, and cotangent x secant x is equal to cosecant x. The reciprocal identities. All of the reciprocal identities can be found by going through the 1. Pythagorean identities. For example, prove that cosecant squared theta minus cotangent squared theta over cosine theta is equal to secant squared theta. To prove, use Pythagorean identities number 7 to get 1 over cosine theta. 1 over cosine theta is equal to secant theta. Secant theta is equal to secant theta. So use reciprocal identity number 2 to get secant theta. Number 2, prove that sine raised to the power of 4 plus cosine squared is equal to sine squared. Sine squared b times sine squared b plus cosine squared b is equal to sine squared b. Factor sine raised to the power of 4 plus cosine b sine squared b. Sine squared b times 1, which is sine squared plus cosine squared is equal to 1. So sine squared times 1 is equal to sine squared. Use Pythagorean identity number 6 to get 1. So sine squared b times 1 is equal to sine squared b is equal to sine squared b. So multiplicative inverse to get sine squared b. So that's all. Thank you. Grabe. 8 months.